Good morning, everyone. My name is Koloko Sekong. I am currently a Master of Engineering student at University of Wollongong. My major is Mechanical Engineering. Today, I will be presenting my research on welding repair dragline bucket for mining industry. Let's get started. Here is a quick overview of what I will cover today. I will start with the introduction, then I will go to literature review, research design, and finalize with conclusion. Let's start with uh, some background of this topic. Dragline buckets are the massive equipment used in the mining operation to move large amounts of soil and rocks. Due to the high force condition, this bucket experience significant wear, leading to frequent failure and high repair costs. One common solution to extend their life is the harvesting method, which involves adding the protective layer to the bucket surface. However, applying multiple layers may create stress, which can create crack and reduce the overall quality of the repair. The aim of this research is to improve the wear resistance and reduce stress in the repair bucket. Next, let's talk about abrasive wear. Abrasive wear is the primary cause of the dragline bucket failure that can occur when the bucket against rough surface like rocks and create high stress on the tool. And many studies have shown that over 50% of wear is abrasive wear. Moreover, research indicates that the bucket teeth is a weak area on the tool. This is shown on the right picture here. So understand this wear mechanism help in developing effective repair method and testing criteria. Next, let's focus on harvesting techniques. Shear metal arc welding is one of the commonly used methods for applying in the harvesting method. And studies have shown that factors like dilution levels and welding sequence significantly affect the quality of the harvesting layer. For instance, appropriate dilution level is set in between 20% and 45% that can improve wear resistance, and alternating welding sequence can reduce residual stress when compared to the linear sequence. Moreover, using harvesting material like carbon and chromium can improve wear resistance for bucket teeth. The picture on the right shows that harvesting material of H1 and H2 that have higher carbon and chromium content than H3 and H4. So H1 and H2 have minimal weight loss after wearing testing compared to others. For abrasive wear testing, this literature shows that pin-on-dump test can replicate the dragline bucket application. And the concept of this testing is shown on the right picture here. The tool material is functioned as a pin, then pin will rotate around the dump, which is covered with a rough surface. So the wear can be directly measured by loss of material on pin. There is many gaps from the literature. One of this is the lacking of understanding how different of the dilution level and welding sequence work together to affect the wear resistance and stress distribution in the harvesting layer. This leads us to my research question. How can I optimize dilution level and welding sequence that can reduce residual stress while enhancing wear resistance in the dragline bucket repair? Moving on to the research design. My study research design aimed to address the gap. I used shear metal arc welding to apply 3 layers of hard facing with 6 different dilution levels, ranging from 20% to 45%, and 2 welding sequence, including linear sequence and alternating sequence. And to evaluate the result, I measure wear resistance using pin-on-dump testing and measure residual stress through the microscope. This experimental approach can provide the optimal parameter which improve wear resistance and reduce stress. For the advantage of my design, first, the condition used in the experimental can simulate the actual environment. Additionally, the comprehensive analysis of different parameters provide insight that can determine wear resistance and predict the lifespan of the product. However, there is one limitation that the study does not include long-term testing and validation. To conclude my research, this research aims to optimize welding parameter to improve dragline bucket wear resistant, and reduce residual stress. By doing this, we can extend the life of this critical mining tool and reduce downtime that can reduce repair costs significantly. And finally, I would like to recommend for further research to focus on the long term of experimental design. And this is my reference list that I provide in my presentation. And thank you very much for your attention.